All right, so here's our warm-up for section 2.1. We are starting 1414 today. Section 2.1 is the rectangular coordinate system. Our objectives are to determine the quadrants, ordered pairs, x and y intercepts, graph from a table, determine the midpoint and distance. So this is like an introduction to all of chapter 2, and so there's going to be a lot of definitions and formulas and things like that. So this is just an overview of some of the important formulas in the key vocabulary. Hello, good morning. Starting with x-intercepts, y-intercepts, and then we'll talk about midpoint and distance as well. All right, so I'm going to start with x-intercepts. So for the definition of an x-intercept, you may remember from the past. So the x-intercept is the x-coordinate of a point where a line curve or surface intersects the x-axis. It is usually written as x, 0. The y-intercept, which I'll do down here, has a similar definition. So the y-intercept of a point where a line, curve, or surface intersects the y-axis. And I want you to think about how would I write that. So if the x-intercept is x, 0, what do you think the y-intercept would be? Yes, very good, yeah. Algebraically, to find the x-axis, or the x-intercept, all you do is plug in 0 for y and solve for x. And then to find the y-intercept, you plug 0 in for x and solve for y. And we're actually going to be doing that today in some of our homework examples that I printed out. Okay, so those are the first two definitions, x and y intercepts, that are not really in that little note packet I gave you, so I wanted to make sure to talk about it. Now I'm going to go ahead and move into the midpoint and distance. You may have seen the midpoint and distance before. This is something that you will be using in this section. Is it okay for me to click? You guys are good? Okay. So please write these formulas down. I'll try to kind of zoom in a little bit. The midpoint formula, basically it allows you to find the middle of, or the center between 2 points. And so if you have two ordered pairs, which we should probably list, x1, y1, comma, x2, y2. So if they give you two ordered pairs and you try to find the middle, it makes sense that you would add the x's together and divide by 2. You would add the y's together and divide by 2, and that would give you the middle. It's kind of like if you took two tests and you got an 80 on one test and you got a 100 on the second test, and your average would be a 90. It would just be adding them together and dividing by 2. And then we also have the distance formula, which you're going to see in this class to begin with. And the distance is equal to the square root of of x2 minus x1 squared plus y2 minus y1 squared. And it does point out that it doesn't matter which ordered pair you use or list first, you just want to make sure it's uniform within the formula. So if you do x2 here, you want to make sure to do y2 there. And we're going to do some examples with this as well. So let's go ahead and move into the notes for section 2.1, sorry. So you might want to change this to 2.1 first. That should say 2.1. We have the update version of the book. Okay, so this section is the rectangular coordinate system and graphing in general. So we're going to talk about how to write an ordered pair, how to figure out what the ordered pair is. That has to do with the x and y axis. And so on the coordinate system, the x-axis is the horizontal axis in the rectangular coordinate system. It determines if the ordered pair will be located left or right from the origin. And so all that is saying is that, so the y-axis would be vertical, the x-axis is horizontal, the y-axis is vertical, which means that it determines if the ordered pair is going to be located down or up or down would also be true. And I just want to point out that, to be even more specific, the left implies negative, the right implies positive, down would be for negative, and up would be positive, right? And I think that's very intuitive. So one of the basic ordered pairs that we start out with, one of the basic objectives, that we start out with in this class is to find an ordered pair on a graph. So I'm going to give you a moment to try to find the ordered pairs of the following cities. And it says that a point in the plane is defined as the ordered pair x comma y, such that x is determined by the horizontal distance from the origin, and of course y is that vertical distance from the origin. And so you're going to write these as ordered pairs. Now I'll do the first one for you, and then I'll give you a chance to try the others. So if I'm trying to find London, I always start at the origin, and I'm going to have to go left to right first. And the reason why I want to go left to right first is because alphabetically, x goes first, and then comma y tells me up or down. So it's almost like you're giving directions to someone. I would say go to the left 1, 2, 3, 4, 5, 6. So London is at -6 for the x value. And then I would tell my friend to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And since I said to go up, that would imply that it's positive. So I want to give you a moment to try to fill in the rest. All right, I'm going to go ahead and fill in the rest of these. So for Berlin, I got to the right 3 and down 4. So 3, comma, -4. For Paris, I went to the left 4 and then up 4, so I got -4, 4. For Bern, I went to the right 3 and I went down 4, so I got 3, -4. Madrid, I went to the left 8 and I went down 8, so I ended up with -8, -8. And then for Rome, I went to the right 7 and down 9. Did you get the same? And are there any questions on that part?
For Berlin,
Uh-huh.
3, 4.
Oh, what did you get?
8.
Oh, I accidentally did Bern twice. That's hilarious. Okay, thank you for telling me that. 8 and 8, right? My bad. Bern, Berlin, same difference. No, I'm just kidding. Actually, I need to fix that on my paper. Fix that. Okay, so this should be 8, comma 8. Okay, cool. All right, let's now do the vice versa, which says to plot each point based on, they give you the ordered pair, now you're going to graph it. So I'll give you a moment to do that. Okay, so 2, 3 would just be to the right 2 and up 3. Oops, sorry. Let me zoom back in. Okay, that would be about right here. Okay, and then -4, -6 would be to the left 4 and down 6. 0, 2.5 would be, now that one's kind of hard to do, right? Because I don't get to go left or right because of the 0. I only go up, and then I have to go in between 2 and 3, and I'm a human, so it's not going to be perfect. So just do your best to kind of get it in between 2 and 3. And then -3, 0 would be right here. 8, -2 is off the graph, but that's okay because we know the graph actually keeps going forever in all directions. So we can estimate that it would be about right there, even though it's off the graph. And then 0, 0 is at the origin. Are there any questions on that first objective? Okay, so we can just check that one off, right? So now we're going to be talking about quadrants. So on the rectangular coordinate system, here is what the quadrants look like. There are 4 quadrants. It goes counterclockwise, starting in the far right. So I'll give you a moment to try number 3 that says name the quadrant or axis where each point lies. Okay, so I'm going to start with negative 4 comma 1. So negative 4 comma 1 would be to the left 4 and up 1. So that would be quadrant 2, because it would be about right there. And then for the next one, I have negative 4, negative 2, which would be down here. That would be 1, 2, 3, whoops, 4. Okay, so that's quadrant 3. And then 4 comma 6 would be in quadrant 1. You can see that all of when they're both positive, they're always going to be in that first quadrant. And then 0, negative 5 would be down here. Now, that does not lie in a quadrant. So if it lies on one of the axes, it is not in a quadrant, or if it lies on the origin. So I can just circle the y-axis because it's literally on the y-axis. Remember, this is the y-axis. And then in red, I'll do the x-axis. Any questions about quadrants? So we've got a lot of objectives today, right? So we did the ordered pairs, we did the quadrants, check, check. Now we're gonna run into the x and y intercepts, okay? So the next thing we're gonna do is identify the x and y intercepts graphically, and then we're gonna practice one on your homework where you actually have to do it algebraically. And there's a few on your homework where that happens. So we're going to estimate the x and y intercepts from the graph. And for my x-intercept, remember, I'm just trying to find where does it cross the x-axis. And it appears it crosses the x-axis right here, which is at 3, 0. And notice I always write my x-intercept as an ordered pair, x, 0. In this case, the x is 3. And then for my y-intercept, it appears to be right here, and that's at 0, 3. And if we could zoom in on that circle, we would see that it's just barely touching. And I know it kind of looks like it's touching in more than one spot, right? If you imagine if you were able to really, really zoom in, it appears to be crossing just at that one spot. And it does say estimate. So, that's good as well. So I want to give you a moment to please try number 5. There's going to be more than one x-intercept here. Yeah, you did. Okay, so I actually have 2 x-intercepts, and you can have many x-intercepts. So I have 2. I have negative 2, 0, comma, 2, 0. And listen, when you type this into your homework is really picky. You're going to want to type it in with parentheses and a comma in between, and it'll tell you that on your homework as well. So we are getting into your traditional homework assignments this week. All right, and then my y-intercept is at 0, negative 4. All right, so that concludes the first part of our notes. Now what we're going to do is we're going to jump into some of your homework problems. We're not going to do all your homework problems, but I did print them out for you. I want to focus on the midpoint and the distance because we didn't have any examples like that, so we're going to do some that are from your homework. And I also want to talk about finding the x and y intercept algebraically.